Hi, welcome back to the another lecture in process control automation subject. So this is Nagarjuna and today's topic is PLC, Programmable Logic Controller. So now the PLC programmable, the word programmable means it's nothing but it's flexible, like or any device, if it is a digital or if it makes use of a microprocessor or microcontroller, then we can write some set of instructions, nothing but we can write some program. So when we can able to write a program to a device, then it means it is giving some flexibility to us where we can able to change the algorithm as per the requirement, as per the need. So here the PLC also, it is a programmable device where we can write the logic, we can edit the logic, we can change the logic as per the requirement, as per the process automation requirement. So this allows us to edit, and customization is one of the major advantage with the PLC. You know, in the last previous lecture we discussed about relay logic, where in the relay logic it's a fixed board. So all it's a hardwired and all the components are fixed, and edit it's not a possible. So here we can able to do that. Next comes with the logic. So what is the logic? It's nothing but an analysis or a reasoning or something like some thought process or logical thought. So I can say it's like an idea. So you can able to achieve the process automation, or we can able to do the automation things by an idea or by just some, if you have some reasoning or if you have some thought, like say for example I want to pick and place an object. So how to pick and the object, how to hold the object, and how to place in a position B from A to B. So it's just about a thought, right? So if you have a thought and if you have an idea how to make the automation, then you can write a program. So most of the PLC programs are logical based. So given a thought, then you can implement that using the PLC instructions. Next comes with the controller. So you know the controller is a main component. It is responsible for your process automation. So all your things, all the automation things can be controlled, managed by the controller. So in the PLC, so your thought, your idea, your reasoning can be implemented by a set of instructions, and then it's nothing but it's a program, and then by based on this program, you know, the controller will execute and it will perform all the tasks for you. So whole together it's a, I mean the name, it's a PLC, programmable logic controller. Now when it comes to the application, so it has a large applications, as you can see that in process industries, in steel, in petrochemical industries, nuclear industry, chemical industry, power industry, and not but I mean finally in the home automation also we can use the PLCs. So wherever there is a need for an automation, wherever there is a demand for an automation, these PLCs will come into the picture. So you can make use of this. So it has found a wide applications. Now let's look into the detailed internal architecture of the PLC. Right. In the previous lecture, I have given you the general overview of the PLC. Now we will see in detail about the architecture. Right. Now, as I said, this PLC is a microprocessor based device. So definitely you can expect a processor in it, and here in any processor the CPU is one of the major components. So CPU, central processing unit, will process the instructions. So again, the CPU alone cannot do anything, you know. CPU needs some memory devices, so it makes use of the ROM, read-only memory, or nothing but a permanent memory, where we can able to load some operating system related things, and then also the program, right? So the user program will be stored in the ROM, right? And in association with this CPU memory, you know, there is a, I mean we need a for computing we need this timing and control unit, which is responsible for the timingly operation. Then we need a ALU, arithmetic logic unit, for all the execution purpose, and ALU is supposed to be the major component in CPU. And then some associated registers, because for performing this arithmetic and logical operations, so CPU, I mean this ALU will make use of the internal registers, right? So all these are very much essential for computing. So for any microprocessor, microcontroller, or a simple basic computing device, these are the one of the most essential components. So in PLC also we will find all these computing devices. And now comes to the major part, that is you can see some peripherals. So we will talk about these peripherals later. Now the major thing is here we have the the in the basic overview I mentioned about the input module, CPU, and the output module, right? So input module is responsible for acquiring the inputs, the information, the field information from the sensors or the transducer. So this information will be given to the CPU by proper optical isolation, because I said there is no wired communication. So similarly, and in the CPU, the execution takes place, and then the decision is being generated, and that decision is again sent to the output module, and from the output module the device will be get turned on or off. So this is what we discussed in the last lecture, right? Now when it comes to the input module, the field information will be given to the input scan block. So what is an input scan block? See, input scan block, it is a general fundamental of the CPU, right? When a CPU is when a PLC CPU is in under the execution, it always performs a scan. So with the help of the scan, it can able to read the input status, right? So whenever it performs the input scan, the inputs get updated. So that information will go to the input scan block, and here in the input scan block, it has an entry, it has a register where it holds all the input status. So which input is on, which input is off. So the status of the sensors will be stored in a particular register, and that register will get updated with respect to the scan. Then we have the logic scan. So logic scan is nothing but the program scan. So the user program will get executed, and it will verify, and then based on the logic, the decision has been generated, and that decision again it will be given back to the output. So output scan is again, it is responsible for the outputs to get updated. Say for example, previously an output was off, it was in off state. Now based on the decision, based on the logic execution, a new decision has been taken to turn on. So that turn on will be done based on the output scan. If there is no output scan, the output will be in it's in same state. So there won't be any updates at all. So overall, when you look into the internal architecture of the PLC, so it has some computing devices. The top section is a computing devices, and the bottom section is the input output module and about the scan process. So totally we have 3 scans: input scan, program scan, and output scan. And now here, so the most of the PLCs are supporting the serial communication or LAN communication. So with the help of this communication, we can have some peripherals. We can connect some peripherals, and also you can have some interfaces. So you can connect to the external devices with the help of this ports, right? So now let's move on to the scan cycle. We will try to understand this scan process in detail again. So here, as I said, this scanning will be done continuously. So it's not like that the PLC has performed an input scan followed by program scan and then output scan. It's not like a one-time process. It's a periodic process. So the PLC has to perform these tasks continuously, periodically, right? Why it is so, I'll tell you. See, from the input terminal is across the input module. So where we will connect all these sensors. Say for example, I have connected 2 sensors, right? So it is a proximity kind of a sensor. So S1 and S2, I have connected 2 sensors, right? Now the status of the sensors, as I said, is a proximity. So it will give you as a on or off. So on means 1, and off means 0. It's a binary. So now this the signal, across the terminal, the signal will enter. The supply will go to the terminal. Then that supply will be converted into logical binary 1 and 0. So when it performs the input, in the input table, when it performs the input scan, the table gets updated So the corresponding channel. So because I'm going to connect this S1, S2 to a particular channels of my PLC, so the particular channel will got a entry. So that entry will be like, say for example, 0 and 1, which means the sensor S1 is off and S2 is showing as a 1, right? So this 0 and 1 is updated with respect to the input scan. So input terminals are read, and the input status will get updated. Then this 0 1 will enter into the user program. Let us say I have written a simple AND logic. I have written a AND logic, and you all know the AND logic. If both the inputs are high, if the two inputs are high, then only you will get an output, right? So when I look at these inputs, one of the input is 0. So which means now, as per my logic, as per my AND logic, what the decision is, the output is 0. So that output 0 is a decision which I made with respect to my input and with respect to my logic. So now input scan, you will get this data. With a program, user program scan, you will execute the logic. And now I got the output as 0. This is the decision, and with the help of output scan, this 0 will go to the output terminal. So across this terminal, let us say I have connected some lamp. I have connected a lamp. So now the status of this lamp is off. Why? Because as per my inputs, now the decision is 0, so it is off. Let us say now the S1 status has changed. It has changed its status to high now. It has changed its status to high. So now with respect to this new input, and this entry will get updated only if provided if it performs the input scan. That is the significance of the input scan. So if suppose if the input scan is not done, right, so if it has scanned only once, then the last time during the scan process, whatever the data, only that will get into the picture, right? So that is the meaning, and that is the reason why the PLC has to perform scan process continuously. So now, so hence the PLC has done the scan process, the input scan process, the new data will get updated, and this new data will, again, the user program will get executed. It's not like that the program will be executed only once. It goes on, it continuous process. So again, as per the new data, now the logic says, and I have not changed the logic, so same logic. So now with respect to input, now new decision is it's high, right? So the new decision is high. So now what happens, this decision again with respect to the output scan, it goes to the output terminal, and this time the lamp will turn on, right? So that's the reason why a PLC has to perform continuously. It has to perform the input scan to read the data continuously, right? Because in the real time, the sensors will change its status from 0 to 1 and 1 to 0 continuously. So we need to update it continuously, and then we have to scan the program, because when the data changes, when the input status changes, then immediately the program, the decision has to be changed. It's not like that whatever the decision is taken previously, that's the final. No. So whenever the input changes, the decision has also will get changed. So again, program scan is also compulsory. And then finally the output scan. Why output scan? Because the previous output was, in our example, it was off. Now it has turned on, so we need to update the output. So we need to change from its status, right? So this is a cyclic process. So input scan, program scan, and output scan. Clear? So this is how, in a PLC, the scanning process will go on. I hope it is clear, right? Now let's move on to the next. Here I have mentioned some of the PLCs. So I have taken Siemens PLCs, and here in any PLC, if you take any PLC manufacturer, there are small PLC to large PLCs. Every manufacturer will do that. So in Siemens, when you look at, right, so here they have started their PLCs device in 1970s, right? So Logo was one of their first version of the PLC. It's a very small PLC. It has only digital inputs, right? And then they have introduced S5, S7. S stands for the step, and step 7, 1200, they are very popular PLCs, right? So, and then they have the advanced series large PLCs, that is S7 1500, S7 300, and S7 400. All these are large PLCs, where when I say large PLC, it means that it can able to handle a high computation. So you can able to connect more number of inputs and outputs. And when I say a small PLC, it means it has a limited number of inputs and outputs, and the computation is also very less, right? So large PLCs, more inputs and outputs and more computation it can able to handle. And then it has a distributed controllers. It is called ET200, or another way we can say it as an RTO, remote terminal unit. And it has got SCADA, WinCC, and it has got a VFD, variable frequency drive, G120C. These are all very popular devices. Of course, the RTO, WinCC, G120C, these are not related to the PLC, but anyhow, in automation we'll make use of all these things, right? And also we will learn about all these things in the future, right? And not only Siemens, I have covered some Allen Bradley PLCs as well. So here Allen Bradley offers again the three variants: micro, nano, and large PLCs. So here under the micro, we can see that 810, 820, 830, 850 controllers, these are all comes under the micro PLCs. And here we have Micrologix 1400, it is also very popular PLC. And small control systems, we have SLC 500 controller. And in the large category, we have 1753 GOD PLCs. So this is from Allen Bradley, right? Now, why I have taken the Siemens and Allen Bradley? Because the major contribution, I mean, the major in the worldwide in automation, the most widely used controllers are these two only, right? Now let's look into these S7200. I have selected this particular hardware. I just wanted to show you the specifications of this particular device. So here is a hardware. So how these S7200 look like. So here you can see the Siemens, the brand logo, and here is the model, right? S7200. And here you can see the CPU. There are different variants of CPUs available in the market. So here it is a 1215, whereas DC, DC, DC. So what is this three DCs indicates? So first DC indicates it's a input type, the input module type. So it's of DC type. And the second DC indicates the CPU power rating. So CPU of this particular PLC again supports the DC. And the third DC indicates that the output module. So again the output module. So it's a power specification. So input module is of DC type, CPU is of DC type, and the output module is also of a DC type. Clear? So that's the main significance of this thing. And next comes to the here this is indicating the input LEDs. This is indicating the input LEDs. So you know the digital inputs, right? We discussed in the previous session. So digital input, whenever the inputs are when they indicate high, then this particular LED will be going high. And this is a output LEDs, digital output. So we don't have a indication for analog inputs and outputs. We have only for digital inputs and output. And here on the left hand side you can see some status indicators, right? So now let's look into the specifications again in detail. So here the CPU, this 1215 has a 3 DCs. I just now I mentioned what is the significance of this 3 DCs. It has a 14 digital inputs, 10 digital output. I mean specific to this 1215, right? So I mean this specific to this 1215 CPU model. It has 14 digital inputs, 10 digital output, 2 analog inputs, and 2 analog outputs. And in addition to this, it also supports 2 Profinet ports. It has 2 Profinet ports, and it supports it works with 24 volts DC, right? Now when I say, I mean it has 14 inputs and 10 outputs, and then suppose if I'm working I have some application where I need around 20 digital inputs, 20 digital input, whereas in PLC onboard, remember onboard I have only 14. So what is the next thing? I mean, do you need to change the PLC? No. This I can increase or I can customize these inputs and outputs, right? So whatever the specifications are mentioned on screen, these are onboard input output specifications, whereas you can change these numbers, you can increase, right? You can increase the number of inputs, or you can increase the digital inputs outputs, or you can increase the analog inputs and outputs as per your need. So you will get a modules, input output module separately in the market. You can bring and you can connect to this PLC, and you can expand the number of IOs. So as per your project demand, as per the requirement, you can change, you can increase the number of IOs, right? It's not like that whatever is specified, that's freeze, right? That's it. I mean, the PLC cannot handle beyond this input and output. Yes, it will handle beyond this, right? This is just an onboard input and output, right? Then to work with this PLC, we need a software called TIA Portal. TIA stands for Totally Integrated Automation Software. So this is an application where we can able to write the ladder logic or whatever the programming that you want to write. So we can write the, we can develop the application, we can dump into this hardware, right? So that's it for today's session, and we'll continue in the next lecture. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.